Hello, welcome back. Today, we'll be going over a game I built in C++ using the game library Raylib. The game is incredibly simple to implement. Let us begin by actually playing the game. But first, I actually want to get rid of just 2 lines. And now we can build it and then run the game. And here we go. The game is called Arkanoid. It's a classic arcade game. At least when I first played it, I actually played it on mobile. But this is the game that we will be building today. And if you notice in the bottom left corner, we have our current score. Let's see what score I can get. Damn it. So a score of 6. Okay. What's this? Oh, hide. Cool. So what we should do is Control A to select everything, and then we shall nuke the file. Cool. What are the requirements for this? C++ and have the Raylib library installed and somehow linked in some way to our entry point. In this case, our main.cpp file. I think the easiest way for you to do that is to download Qt Creator 6 I should say, and then download Raylib and then just copy Raylib's cmake file or the contents of it into the cmake file that comes as a base cmake file when you create a project in Qt 6. Okay. We now need to break down the game and understand what we are trying to build. If we actually go to the Raylib official website, it just happens to be that they also have an implementation of the game Arkanoid. And this is the game. Okay, and you can actually play it on the web. If you see right here, you can actually play the game. We notice we have 3 entities of interest, one being the paddle, which is the player, the second being the ball, which is the object of destruction, and the third entity is the brick, which is the object we intend to destroy. So these are 3 entities we must keep in mind. We also need to do just a little work on understanding frame rate, which is simply the number of times the screen is redrawn in a second. And how can we implement motion in our game? To do this, let's write some code. Let's go back into our Qt Creator and do all the necessary imports. So you obviously are going to need Raylib. And apart from this, I can just begin writing code. We'll create our main function, int argument count, and then char argv. And just a very simple main function for now. And what we need to do is just write a little code using or leveraging some of Raylib's internal data that is available for us. So if we notice, we have this init window function, and this is the function that is used to create the window that we'll be playing in. It takes in 3 parameters, a width, a height, and title. I'm just going to go, let's go 420, 420, and my first window. And apart from this, we have to set our target frames per second. Let's set it for 60. This should mean the screen should be redrawn 60 times in 1 second. Apart from this, we are going to do the following. We'll create a while loop and we shall say while window is not closed using the window should close function. We shall open brackets, and this is where all our drawing will be done. And I want a close window function. And this one, as you can see, it closes the window and it unpacks Raylib. We also need to do a clear background function that takes a color. In this case, we'll pass in white. If you are interested in learning about the syntax of Raylib, just go to the official website and download the cheat sheet. It's just a 2-page PDF showing you everything that you should know. We'll now in here create a call a function called begin drawing, and call another function called endDrawing. And between these two functions, this is actually where all our drawing will be get done. And we are simply going to come up here. Let's create a global variable. It's going to be a color type. Color is actually a type in, let me actually go ahead. Color is a type in Raylib's predefined types. Or should I say Raylib primitives. And there's going to be called colors. And it's going to be an array of colors. Let's do black, blue, red, yellow, and green. So it is an array of 5 colors of size 5 consisting of 5 colors. And all I want to do is I want to do for int I equal to 0, I is less than 1, I plus plus. It's a very simple for loop that should run one time. Right. We are going to call a draw rectangle function. And before we do this, I just want to save everything. And I'm actually going to open up another window. And I'm going to bring up, oh, where is the grid? Okay, here we go. I want to bring up draw.io. If you are familiar with coordinate planes and the traditional coordinate system, you are familiar with the XY coordinate system. So just a line there, your vertical line, and your horizontal line. And you know that this is the origin, indicated by a 0x and a 0y value. However, in Raylib, this is not the center. Actually, this corresponds with the top left corner of our window. So it's still going to be 0, 0. Let me actually come here and create text. It's still going to be a 0x and a 0y, but it's not going to be the center. It's actually going to be the top left corner of our screen. If I told you the following, if I said plot the coordinates 1, 3 on the plane, how would you do it? Well, you would say, well, let's say we're given this is 1, this is 2, and this is 3, and this is 1, this is 2, this is 3. Come down here, we have the inverse, -1, -2, -3, and then similarly on the x-axis we have the negatives, so -1, -2, and -3. How would you plot the point 1, 3? You should say move 1 on the positive x-axis and then move up 3, so it should be somewhere here. That should be your plotting. However, in Raylib this is not the case. In Raylib, x coordinate plane stays the same, so a positive x value will still move you right. A negative x value will still move you left from the origin, but a positive y value will actually move you down, and a negative y value will actually move you up. So there's a little nuance that you should catch on to. So when we draw this, it will actually be, let me change color. It will actually be come down from the x-axis 1 and meet it here at -3. And this is where that point 1, 3 will be in the Raylib coordinate system. That is something that you should know. Apart from that, as stated, if you aren't sure where I'm getting all these functions from, just go to the Raylib site and download the cheat sheet. It's a 2-page PDF that will teach you or show you everything that you need to know. So cool. So I'm going to save this. I'll leave the window up and I'm going to go back here. And then going to refresh my mind on how to generate random numbers. I think I need a few other libraries, or at least, yeah. So I think I should need ctime and cstdlib. Okay. I first need to seed my time, so I'll do it up here. srand time and time 0. And then down here, I'm just going to pass everything required to create a rectangle. You notice it takes an integer position x, so that's a coordinate space. Let's go 100 to the right and then 100 down. This is a positive y value, but it's still going to move us down because, as stated, the axis movement is inverted. I want this rectangle to be 50 in width, 50 in height. I'm going to give it a color of, and this is where I want it to be random. So I'm going to call my colors array. And as for the index, I'm going to say rand, the random function, divisible by 5. Just going to end that. Now, how many times should this rectangle be drawn? If you notice, we are in a for loop that should run only once. So you should say 1. Let's see what happens. Let's do a control B to build, control R to run, and instead we get this. We get this very weird flashing rectangle animation that goes on the screen. Why is that? Let me grab a sip of tea and check how much time I have left. 11 minutes gone, so I have enough time. Okay, cool. So what's happening is, as stated, this function here, set target frames per second, is the refresh rate or the frame rate, and it defines the number of times the screen is redrawn in 1 second. So if we actually change this from 60 to 1, it should mean that in 1 second, the frame should only be redrawn once. Control B to build, Control R to run, and there we go. It's going to be much slower. You can actually count it. 1, 1, 1, 1. Okay, cool. So now we understand what we need to understand, which is this very important part, which is the frames per second, the refresh rate, or the frame rate. And we'll keep this at 60 because that's just an appropriate level of refresh rate. Let's get rid of this. And we can come up here, and we can actually also get rid of this array. We don't need it anymore. Again, now that we understand that setting the frame rate defines the number of times code in this section is going to run, it simply means the number of times the screen is redrawn in a second. Based on what we've learned so far, we need to initiate 3 actions. Action 1 should initiate our starting game's state. Action 2 is the first frame will be drawn, which will be based on action 1. And then action 3, updating the game, which in other words, playing the game. These 3 actions will correspond to functions. And we will now finally move on to the coding part. And again, keep in mind, I am referencing the Raylib cheat sheet because I don't know the syntax that well. It's just a 2-page PDF that provides you with everything you need to know to get started. So let's do step 1, which is setting up our global variables. Not best practices, but it is what it is. Just in case I need to print out some values, I'm actually going to use the namespace standard. The first thing I want to do is I want to create 2 constant variables that refer to my screen width and my screen height. I already did this and I found 900 for width and 720 for height to be good values to work with. So let's just ensure everything here is working. I'm going to get rid of this init window function and I'll recreate it. And I'll pass in screen width and I'll pass in screen height, and I'm going to shut up unless it's something important. Cool, that's our window. 720 pixels width with a 900 pixel height. So again, step 1, create our variables, our global variables. Step 2, create our entities, which is our paddle, the ball, and the brick. Step 3 is create the functions which correspond to the 3 actions I spoke of. And step 4 is profit. I think I can get this done in 45 minutes. I am only explaining the Raylib specifics. I am not explaining C++ that you should be familiar with. Let's begin. But first, tea. Okay, cool. So we just created an object via the struct keyword in C++ called paddle, and you can see that it takes in a color, which is obvious. It's just a enumeration type from Raylib that defines a color. What you may not be familiar with is vector2. Let's go back to our drawing. Here, how many windows do I have opened? Oh, get that closed. Let's say that we had a vector2. Let's say I gave you the vector u, and I said it was equal to 1 and 2. Okay. This just defines a position in space, which says go right 1 on the x-axis and 2 up on the y-axis. And that's all a vector can be considered for now. You don't have to worry about the linear algebra part behind it. We don't need that. You can just think of a vector2 as being a C++ vector, but limited to only 2 entities, x and y, that you can have to be set to whatever you want. But again, its components are only 2, an x and a y. Let's go back here. The same for size. So this is going to indicate in space xy, which will equivalently be set to position x and position y. And this is also going to be an x and a y, but this is actually going to indicate the width and the height of the paddle. And color is just the color. You can use a class here instead of a struct, but it won't work. Not because there's something wrong with using a class, just because by default, a structure has everything in public scope, whereas by default, in a class, everything by default is in a private scope. So if you are going to use a class, just make sure you use the public scope specifier. But we don't need that because everything will be public. I'm going to create a struct called ball. How much time do I have left? A little less than 12 minutes, okay. The same thing with the ball. It has a position in space. It has a speed, which will define how fast it moves in the xy coordinate system, a float r, which is just the radius of the circle, and a color c. And we will create our last entity, which is a brick. This bool active determines if a brick should be drawn or not. I'm actually also just going to create 2 constructors, a default constructor. If we actually call that position member and we use the dot operator, you see it only gives us access to 2 values, an x and a y. Both must be set to a float. And I want an overloaded constructor which will actually take some parameters. And this one will be set to true by default. Because by default, I want all the bricks to be drawn. And then I'm just going to initialize those member variables to the appropriate values. X is going to be set to X position, Y is going to be set to Y position. The size X is going to be set to the width. Should be set to the length. And size Y will define our width. And active, if we do set it, will just be set to active. Okay. That should be fine. And if you recall, when we first played the game, I actually had a scoreboard in the bottom left corner. If you want, you can implement that yourself in whatever way you wish. I just created another structure and did it that way. Around 7 minutes, okay. So as stated, let's just do a Control B to build. And everything went through. We now need the first function that will be used to initialize the first starting positions of all our variables. And to do that, we actually need to create some variables, don't we? We're going to create a constant integer called rows, set it to 2 because I don't intend to change it, and a constant integer called columns, and my one is set to 20. I have played around with the values, and this is the two values that I just chose. You can do whatever you want. We're going to create an array. It's going to be rows. So it's going to be 2, size 2, and within that we're going to have 20. And then we'll create a pedal, just called pedal. And finally a ball called ball. And that should be good. We can now create our first function, which I just call start game. You can call it whatever you wish. And here, we're going to create a float called starting x, which is set to 0. Now, remember, let me just do a Control B to build, Control R to run. This coordinate plane, the center of this window is not the origin. It's not 0, 0. The origin is the top left corner where my mouse is. That's where 0, 0 is, okay? And as stated, the xy axis is inverted, which means a positive x value will still move you right, but a positive y value will not move you up, it will move you down. Keep that in mind. This is going to refer to and we have a float y called starting y, and it's set to 40 because I don't want it on the top border of the window. I meant it just a little lower. The float length of our brick is going to be 45 pixels, and the width will also be 45 because our brick is actually just a square. Why did I choose the values 45? Well, just by playing around, I found 45 worked well. And by worked well, I mean it looked well. Aesthetically pleasing, if you will. How much time do I have left? Not a lot, okay. For int I equal to 0, I is less than the number of rows, I plus plus. For integer j equal to 0, j is less than columns, j plus plus. This is the number of times you'll be creating a brick. And because we have the constructor, we can just pass in the values. Starting x, starting y, length, and width. I'm then going to add the brick that I just created to my bricks array at the given position. And I'm also going to increment starting x plus equals the width of the brick. So that's how much I want to move. So it's going to be plus equals 40, just L. Yeah. Because, let me just go back to the window. Let's go, how much time? Not much, okay. Let's say I had a square and I drew a square there, okay? That's my square. I want the next square to appear to its right. Therefore, I have to move the x value the appropriate distance away from the starting point. So let's say we are at 0 and 0, and this length is 45. Therefore, this brick here must start 45 to the right of the prior brick, but in the same y coordinate space, because I'm not moving down. All right. So starting x plus equal to L, which is just 45. You can equivalently just go 45, but L, because it's the same thing right now, and if we ever needed to make changes, it's good for us just to update in one place as opposed to everywhere. After we create 20 columns, is it 20? Yeah, 20 columns of bricks, we're going to set starting x back to 0 to bring us back to the left corner, and we are going to increment starting y by the 45 as well. So plus equals, this should actually be width, and this is going to be L. Yeah, width and length. Yeah, move 45 pixels down, because once we add a new row of bricks, we actually want it to appear in this first x coordinate space, but 45 below the prior y space, because we're trying to create two rows of continuing bricks. And let's leave that for now. We won't do any other of our variables. Let us move on to the next important function. Let me just add a comment. Very simple. Create our next function, which I called, was it draw first frame? No, I think I just called it draw actually. But yeah, that's what this function does. Draw the frames. The frames is just what appears on the window, okay? Just your actual drawings. I'm actually going to first create an axis, okay? The regular XY axis. Create an XY axis. Create a XY axis. What's my time like? About 2 minutes, okay. Draw line, and I know that it's 450 for the center X, 0. And then we're going to stay 450. And we're going to move 720. And I want to make you blue. Do another draw line, and this is 0 and 360, and then 900 and 360, and let's do black. Okay, let this timer, we have some time. Okay, cool. I just want to come down here to this part. I'm actually going to call this draw function. Remember, this is where our drawing will go. Control B to build, Control R to run. And right now we only have the regular coordinate system. Remember, this is the center of our screen. It's not the origin of the coordinate system. That still is the top left corner. After I draw these lines, what I want to do is draw bricks. And before I draw the bricks, I want to see how much time I have left. About a minute. Okay, that should be fine. I'm going to actually come here and I'm going to go. Alright, cool. So my recording is limited to 30 minutes for each individual video. So I'm just going to break it up into parts. So we now need to draw those bricks, and it's the same thing. We're just going to create a for loop for the number of rows and a for loop for the number of columns. And now we need to do something. We need to figure out a very simple map to determine what color we're going to draw a brick. Let's go back here to our drawing. Let's talk about it. Let's add a few more bricks. I do not want that. Okay. And let's bring you here. And I just need one more brick. Okay. We need to figure out how are we going to alternate the colors between these bricks. Wait, what is happening to my hand? Oh, my old scar seems to be blistering again. That is unfortunate. Ouch. Anyway, so how will we manage the math here? Remember, we are using two for loops, an integer I beginning at 0 and going up all the way to rows -1, and an integer j initialized to 0 going up all the way to the number of columns -1. So how will we alternate between the colors? All we have to do is take the integer I plus the integer j, determine if their sum is a even number. If it is, what we're going to do is say that you'll be color 1, okay? But if their sum is not a even number, then it'll be set to color 2. And by doing this, we're actually going to come up with the following pattern: 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Very simple. Just check if it's even. If it is, draw one color. If it's not, draw another color. And now that old scar is starting to hurt. Well, that is unfortunate. So we go back here. And if we create a conditional, and I'm actually going to hide this. If, good to create space when you're working in parentheses, if I plus j modulo 2 is equal to 0, right? If this is true, I'm actually going to wrap this in another set of parentheses. If it is integer, if it is divisible by 2, if their sum is divisible by 2, and a brick is active, oh wait, I did not create the brick. I actually need to create, in my for loop, I need to create a brick called brick, which is pulled from the bricks array at position ij. Yeah. Cool. And then I can say brick dot active. So if the sum of I plus j is an even number and a brick is active, then all I'm going to do is draw a rectangle, and I'll pass in all the parameters from my brick. So it's position x in space, its position y in space, its individual size, so size dot x, and brick dot size dot y, and finally the color. The color, let's go with blue. And that's that's it. Else if, we can just go ahead and copy this part. That's not what I wanted. We can copy this part. We can go around here, paste it in, open our parentheses, and just change this from equals to not equals to. And then we can go ahead and copy this entire thing again, paste this part in, and from blue, we can go to black, because that seems like a good color palette to work with. And this should draw all the bricks as needed. 2 rows, 20 columns each. And we're already calling the draw function. But if we did this, Control B and Control R, we get nothing. We only get those 2 lines. And why is that? Our drawing function is working, okay? This is indicated by these 2 lines. But it's not working because we haven't called our start game function, which initializes the starting state of our starting variables. So within our main function, all we have to do is call start game outside our loop, because if we call it inside, it would consistently be called, and we'll never get any updates to our game variables. Control B to build, Control R to run. And there we go. 2 rows, 20 columns each, of squares of 45 length, 45 width, with an alternating color pattern of red, red, of blue and black. Okay, the scar was actually caused because my skin froze. And we can close that. And now that we have that, let's go back to our start game function. This section, the next section in our starting game function is for everything else. So the paddle.position, because this is a vector, we can just use the curly braces to call its constructor. And if you look at the overloaded constructor 4, it takes in a float x and a float y. We need to center this on the x coordinate plane and bring it down on the y coordinate plane. If we know that the width of our screen is 900, half of 900 is 450. So it should be that we go 450 and we need to move down. And for fun, we can go 650, okay? So go 450 right, 650 down. This will not work. And the reason why it won't work is because the next parameter we need to set is the size of the paddle, which in this case is 100 length and 25 height. And because of this, we actually need to decrement our position by 50 so that we are in the middle. And then we do a paddle.color and set it to whatever you want, but I think black works well. And we go back to our draw function. We'll come down here and we can call a method to simply draw the paddle. And we'll just use the draw rectangle. You can also use the, where is it? There should be a rectangle rounded. Here we go. Which also creates a rectangle, but the borders have some rounding to them. But I don't really care about that right now. Control S to save, Control B to build, Control R to run. And we get a paddle that is in the middle of that x-axis. Very nice. Obviously, we can't move it around, so you can try, but that won't work. The next variable that we should draw is the ball, and we want the ball just to appear above our paddle. And to do that, we can go back here, and after the paddle, we can say the ball. Remember, the start game function serves the purpose of initializing the variables that will be drawn for the first frame of the game. And to do this, it's the same. Choose a position in space, so call the ball variable you created and set its position. We want it to appear at 450. Actually, I can just do this. I can do 450 and 620. Okay. And then we have the ball.speed, which is also a vector too. This will be the value that is going to be added to our position vector that will define how it moves. If we want our ball to move up, what value of the xy coordinate system do we need to set? If we know that an x value moves us left or right, we want it to be set to 0. We don't want left-right motion. We need a upward motion. So it should be a positive value, right? Let's say positive n, where n is some integer. No, because as stated, in Raylib, actually quite a lot of graphics libraries, I believe also true for Q graphics framework, the y-axis has the motion inverted, where a positive y value will take you down and a negative y value will move you up. So if we want to go up, we actually need negative n such that n is an integer. It can be a float, such that n is a float, I should say. And for that, I'm just going to go with -5. Ball.radius, because the ball is a circle and circles need a radius, and I chose 10 because it seemed to work well. And the ball.color will be blue. Let me just grab Raylib colors here and I'll show it to you. Here we go. This should be it. Cool. Here's the Raylib color palette. These are your default colors. Just hold space and these are the colors that you can work with by default. Now obviously you can change these if you know anything about C++ and how to interact with objects. But for now I'm actually going to go with, let's blue, lime green. Let's go dark blue and see how you look. Dark blue. And then obviously we need to go back to our draw function. And after drawing the pedal, we need to obviously come down here and we need to draw the ball with the conveniently draw circle function. And it takes an integer for center x, an integer for center y, and then it takes a radius, which is ball.r, and finally ball.color. Let's save this and let's actually go up here and change the ball.speed both to be 0 so we don't get starting motion. And there we go, centered. We shall now change this to be -5 so the ball starts moving. Control B to build, Control R to run. And it's not working because we don't have a function that accounts for the motion of the ball. But it should be fine. We'll get to that in a second. We now have the function that starts the game, the function that draws the frames, but now we need a function that handles actually playing the game. And I need a lozenger. Let's come down here and create a function called void function, so it returns nothing. And it's called play game. And the first thing we're going to do is determine where the ball is. If not, ball.position.y is greater or equal to the screen height. In that case, we're going to call the draw function. This just means we have not gone below the lower wall. Because remember, this screen height is not the top of the screen, it's actually the bottom. Else, all we're going to do is say, else if actually, ball.position.y is greater or equal to screen height. And then we shall just say draw text, not rectangle, draw text. And we're going to pass in some message, a really cool message, game over, with positioning at 378x, 360y. You can choose whatever you want. I just found these to work. And black. Cool. All this does, it checks if the ball is still within our game applicable area of play. If it moves to a bottom wall, we don't want it to bounce off. We actually just want to end the game because we failed to stop the ball. If we do come down here, after our draw function, we're going to call the play game function. Control B to build, Control R to run. And we should get nothing because we still aren't updating the variables or the entities in our game. And for now, we can actually remove that XY coordinate plane because I'm sure you have an understanding of what's going on. Control B to build, Control R to run, and a much neater layout. How much time? A little more than 14 minutes. We now need to go in our play game function and account for the easiest thing. This is very simple. We just call the is key down function, and we pass in a integer key. And thankfully, Raylib has some cool constants such as key, and then you just call what key? So key left. If the key left function, if the key left key is currently down, and the pedal dot position dot x is greater than 10, in that case, all we want to do is take the pedal dot position dot x and minus equal 5 to whatever it is. Control B to build, Control R to run, and we can move left. We can't move right, but we can move left. And we will never touch the corner of the screen because we have that little if condition preventing us. Else if is key down, and now we're going to do key underscore right, and now we check if the pedal dot position, make sure I'm actually in the parentheses, and the pedal dot position dot x is less than 790, accounting for the screen width and accounting for the size of the pedal. In that case, then pedal dot position dot x plus equals 5. Control B to build, Control R to save, and now we can move right, and we'll never hit that right wall, and we can move left. This will prevent us from losing the pedal off screen. Ain't that neat? Very simple, and now we have some motion. I just want to make it clear what this function does. Alright. Now we're going to call the ball, grab its position dot y, and just say plus equals to whatever the current ball dot speed dot y is, and we can do the same for the position dot x. And this is because even though it's currently set to 0 and it wouldn't make a difference, if you did want to make a difference at a future point, you can. Control B to save all, Control R, and we'll look at that the ball moves and it's lost, but it is moving. We now need to check this just ensures that if the ball does hit the top wall, we're going to grab its speed, the y coordinate, or the y component, I should say, and we are just going to keep the magnitude of it, but we're going to reverse the direction. And to do that, we just multiply you by -1. And just to show you what's going on, I'll set ball.color equal to red. Control B to run, Control R. You'll hit the top, you'll bounce back, you'll turn red, and you'll go through everything. Cool. And there's our game over state because the ball did touch the bottom wall, which it should not do. We now stretch a little. I actually did this video yesterday, but then my recording software did not work. A little less than 9 minutes or so. Okay. This is quite simple because Raylib has a built-in check collision between a circle and a rectangle, which takes a vector 2 representing the center, which is the ball dot position is a vector 2. We need the balls.radius, and then we need to create a rectangle. We can actually create one just by calling the rectangle class and just call the curly braces constructor. And we pass in the position of our rectangle. So if it happens to be that there is a collision between the circle ball and the paddle rectangle, then all I want to do again is keep the magnitude of the speed, but I want to reverse the direction. So I just multiply u by -1, because if you take any number and you multiply it by -1, it will keep the magnitude of the number, but it will reverse its not its symbol, its sign. And when you reverse the sign, you reverse the direction. And then create an integer called distance. My mistake should be a float. Distance between the player and the ball, which is the ball.position.x minus the paddle.position.x. I then say the ball.speed.x, this is to change the left-right direction of the ball, is equal to distance player ball divided by, and if you ask me where this math came from, a lot of playing around actually, size.x divided by 2 times 4, was it, if I remember, times 4. That's cool. It bounces off there, it touches that, and it wasn't times 4. What was it? Was it times 5? That was crazy direction. No, so something is going wrong here. It is... Oh, okay. Alright, I see. Collision detected, and oh, it's very weird. Let's see. Ball.position.x plus equals ball.speed.x. Check collision circle and rectangle. Ball.speed.y component is reversed. I then take the ball.position.x minus paddle.position.x and I check the time. Okay, a little more than 5 minutes left. Ball.speed.x to be set to the distance of the player ball divided by the paddle size.x. So it's width divided by 2 times 5. And come up here. 0 and 5, as all things should be. Ball.speed 0.5. Ball.position.y, ball.position.x. And they have been incremented by the correct values, otherwise I would have weird motion in the start. Ball.speed.y times equals -1. Distance player. Oh, did you catch that equal sign? Control B to build, Control R to run. Bounce off that, touch the pedal, and we get some proper motion. That's good. Okay. It was a little coding error, I guess. No big deal. But now we have a method to detect collision between the ball and the pedal. We now need to check this is quite simple. This means that we hit the left wall, so ball.speed.x, just keep the magnitude, change the direction. If you're going left, go right. Now we've hit the right wall. And again, if you're moving right, I want you to move left. So I just keep your magnitude, but I change your direction. And Control B to build, Control R to run. Bounce off the top wall, collide with the pedal, collide with the left wall. I mean the right wall. I'm gonna miss you. Damn it. Okay, but we see what's going on. Let's play that one more time. Right wall, top wall, left wall, top wall, right wall, and you can go and game over. Cool. Let's see. Now here's the fun part. We need to math what is happening here. So I'm going to save this. I'm going to stop here. I'm back for a third time. Because as I said, we now need to do the fun part, which is the math to detect the collision of the ball and any brick. Let's go back here. And let's actually just clear this. Hide. Let's say I had some... Wait a minute. Here we go. I had some... Not that. Yeah, cool. Don't annoy me, people. Don't annoy me, software. Do not annoy me. I had a ball and I had a brick. Just a square. There we go. I'm going to just make you much smaller. Cool. This is my brick, okay? And let's for fun say that the brick's coordinates always start in the top left corner, okay? Because that's how Raylib draws. It takes in an x and y, and it takes in a length and a width, and then it creates a brick using those values. Let's say that this brick existed in the top left corner at the coordinates 100, 100, okay? And based on our game, we know that the length of the brick is 45 and the width of the brick is also 45. Based on this, on a rectangle, we know that there are two sides of length that are equal and that there are two sides of the breadth that are equal, okay, the length and the breadth. Because our rectangle has all four sides equal, it's just a square, okay? And we can indicate by saying this side is equal to this side, which is also equal to this side and this side, okay? All four sides are equal in length, that being 45 pixels. For us to get any of the other four corners, edges, vertices, whatever you want to call them, it's quite simple. If we are moving to the right, our y coordinate will stay the same because we aren't moving down. But our x coordinate will be incremented by 45 because that's the width that we are adjusting by. So this is actually 145 and 100 in space. And then the bottom one is going to be, if we move down, we are keeping the same x value, but we will increment by 45 in the y-axis because we move down by 45 pixels. Okay? And then the last corner says, hey, you moved right and then you moved down. This means that you had to have gone to the max right, which is 145, and then gone to the max down, which is 145. Okay? And that is the four vertices of our brick. Let me ask you this. How do we determine the area of a square? If you aren't sure, it's just side squared, okay? That's all it is. To determine the total area occupied by a square. But here's another question. If we know this is 100 and 100, and this is 100 and, 145 and 100, then it's intuitive to say that before it went 145, it was 144. Before 144, it was 143. Before 143, it was 142. And before 142, it was at some point 101, 102, 103, 104, 105. All I'm trying to say is, all we really need to do is determine the space, not the space, the perimeter bounded by our rectangle, which in this case is a square. And if we know all of the perimeter bounded by the rectangle, then all we have to do is check when this circle, which says, let's say it occupies the space, it is at 122.5 and it's quite low, so let's say 450. Let's say it occupies the starting space. Why is my Xbox opening? And you're inverted, that's cool. Just don't ever show your face here again. As stated, 122.5 and 450. Let's say that's where you exist in the starting position. That's where you are, okay? At some point, this ball moves, and let's say it touches this area. What that means is, at some point, its y coordinate is the same as the bottom edges and the bottom border, which is 145. So all we have to do is check if the ball's x coordinate and the ball's y coordinate is in the range such that it is greater or equal to the lower bound and less than or equal to the higher bound here, or here, or here, or here, anywhere around this area. It doesn't matter where it hits. And we can do that by doing one thing. Go back here, and we're going to create another function. We're going to call that function bool in range. It's going to take an unsigned low. An unsigned is just integer with no sign, and an unsigned target. Let's say low is equal to 100, high is 100 plus 45, so let's say 145, and x or target just happens to be 101. All we have to do is say return low is less than or equal to x, and x, not x, why am I saying x? Target. And target is less than or equal to high. What this should check for is 100 less than or equal to 101. That's true. And 101 less than or equal to 145. Well, that's true. Well, if that's true, it means that our ball does not exist somewhere here. Does not exist somewhere here. It must exist somewhere here. It must have made contact with that bottom wall. And if we check for the y, it will also check that if we made contact around here, or around here, or around here. And by doing this, we can simplify the math to just one function that checks if we ever make contact between the ball and any brick. And that is the most fun part of this game. Apart from actually playing it, of course. This is C++, it's fast, so we can create another for loop. I think that the Evil Within 2 is on sale. I should check that out. I'm getting an error there for some reason. Int I equals 0, I is less than number of rows. Oh. No, that's fine. I plus plus. For integer I equals 0. Oh, I see. The comma. Cool. This says, okay, we now are considering every brick at every position. I need to, let's say I have a brick at 100 and 145, and I have a ball.x and the same values 100 and 145 and a ball.y. How do I check? Well, I do if, and I call the in-range Boolean function I created. Why is it giving me an error? Function not viable, requires the... Oh, okay. I pass in bricks, so a bricks refers to the array. The brick at position ij dot x, bricks at ij dot y, no, dot x plus 45, because this is going to give us the upper bound plus 45. It should actually be dot position dot x, my bad. And that should be it. And we also want to check the balls.position.x plus account for the ball.radius. If this is true, and we want to check if the same thing is true, but this time for the y coordinates. That should be position. That should be fine. And finally, and is the brick actually active? Because if that brick is not active, we're not going to consider it, because it should not be drawn. Okay, if this is true, then I want the ball, firstly, to keep the magnitude, but I want to invert the direction. Times equals -1. And then bricks at position ij set to false. That's impossible. A brick is just an entity. And then that should be fine. And at this point, if you did create the scoreboard, this is where you'd increment your value. Control B to build, Control R to run. It touches a brick and we have an issue. It does not work. Okay. Interesting. That's working. That worked. Let's see. If in range bricks at position ij dot position x, bricks at position ij position x plus 45, ball dot position x, and that's the issue there. I see you. I've caught you. Copy paste programming is a bad thing, people. Control B, Control R, and there we go. Isn't that just satisfying? And you've done it. You have created your first game in Raylib. You can make any adjustments that you require or any adjustments that you like. And isn't that just cool? And I didn't intend to lose the game. That's it. That's game over. And you can choose whatever game over states that you want. Bye bye.